All right, so we're gonna do a little bit of a review like always, and then today is pretty simple. We're gonna talk about the planets, but not very in depth, and some movements, and then we will jump into our work for the day, and you can also be playing catch up. Okay? All right, so Monday we talked about the Big Bang Theory. What's the Big Bang Theory? What does it say? Okay, explosion. So this tiny point, and there's an explosion, and then it expands. Next, we talked about blue shift, red shift. Red shift goes which direction? Away. So that makes the wavelengths longer. And blue shift comes toward us, so it makes them shorter. Okay. Then we talked about nebulas and nebular theory. And what are those? Big ball of gas. Okay, gaseous clouds. Then we talked about rotation revolution. Rotation is what? A day, 24 hours. And revolution is a year. Perfect. How many days are in a year? In a regular year, not a leap year. Yes, 365. Nicely done. And then what did we talk about yesterday? Kepler's laws, right? And how many are there? 3. Okay. I did everybody see the Ed puzzle that I put on there? Did anybody complete the Ed puzzle? I did. You did? Did it help you a little bit? A little bit? Say what? What about it? Yes. Yes. Okay. We'll talk about assignments in a little bit here. All right. So today we're going to talk about the planets. So there are 8 recognized planets, and they can be divided into 2 groups. So here are our planets. So which one's closest to the sun? Mercury, okay? So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And we said the other day, is Pluto considered a planet anymore? No, and we're going to find out why, okay? So the inner planets are the 4 that are closest to the sun. So those are Mercury, Venus, Earth, and Mars. So we live on Earth, so we are one of the inner planets, okay? These are also called the terrestrial planets. So some traits that they have are small but dense, and they also have rocky surfaces. The outer planets are the 4 farthest from the sun. So this is Jupiter, Saturn, Uranus, and Neptune. These are also called the Jovian planets. Their traits include that they are large, and we can see that if we go back to the picture, they get larger as they go out, but they are not very dense. They have a gaseous surface, and the atmosphere on these planets is made of hydrogen and helium. We've seen or heard of hydrogen and helium, yes? Hydrogen, where might we have heard of that? Periodic table. And helium? Periodic table. Well, what do you use helium for? Oh, okay. And hydrogen is actually an element that we find in something we use daily. We use daily.
Oh, water.
Water. H2O, right? All right. So in order to be a planet, there are 3 criteria that need to be met. They have to be rounded by gravity. They have to orbit a star. What's an example of a star? The sun, right? Okay. And they have to have everything pushed out of its orbit. Does anybody know which one Pluto does not meet, and that's why it's not considered a planet anymore? Sorry, I can't get the masks. which one of those does it not meet? 1, 2, or 3? Three. Nice try. Okay. 3. So it doesn't have everything pushed out of its orbit. So because it does not have that, it is not considered a planet. Because it has to have all 3 in order to be considered a planet. Okay? All right, the next thing we're going to talk about is Earth's movement. So these terms are super important, and you've seen them already where? Where have you seen this term? If you've done it. In your what? Not yet. Today you'll see it in your notes though. What? Vocabulary, right, it's in your vocab, okay? So up here, we see the term barycenter. And barycenter is the point between 2 objects where they balance each other, okay? So the center of mass where 2 or more celestial bodies, since we're talking about astronomy, okay, orbit each other. So when a moon orbits a planet, or a planet orbits a star, both bodies are actually orbiting around a point that lies outside the center of the larger body. So you can see 2 examples here. Okay, so the barycenter is where the 2 objects balance each other out. Can anybody think of another example where we might be able to balance? Huh? Okay, what else? I'm thinking outside somewhere. A seesaw, right? Okay, so does a seesaw always balance? No, right? Because what do you have to make it balance? 2 people, okay? And the 2 people have to be about what? Same weight, right? Okay, or we would have to add something to one side in order to make it balance, okay? So the barycenter is the point between 2 objects where they balance each other out. Super, super important. So the sun is not stationary in our solar system. It actually moves as the planets tug on it, which causes it to orbit the solar system's barycenter. So the sun never strays too far from the solar system's barycenter because we have to stay balanced. So this kind of looks like a giant seesaw, right? So does everybody see how the barycenter shifted? Alright, so the next term that we need to know is precession. Where did we see this word? In vocabulary too, okay? So this is another super important word. So this is the change in the direction of the axis of the earth, but without any change in tilt. So what does it mean to tilt? To move. So like to shift maybe in a specific direction, okay? So this changes the stars near or not near the pole, but it does not affect the actual seasons. So remember we talked about the seasons the other day, summer and winter. So the Earth's axis currently points at Polaris as the northern star, but it won't always be, okay? And that is because of the tilt. Stare at that too long, it'll make you dizzy, huh? All right, next one is nutation. So nutation is super important as well. We've seen this where? Okay? So this is the wobbling around the precessional axis. Okay, so this is the change in the angle, just a half degree one way or a half degree the other way. So it occurs over an 18-year period, and it is due to the actual moon. So it's very, very slightly increasing or decreasing seasonal effects. Okay, so depending on which way it shifts, it's still not going to majorly increase or decrease seasonal effects. Does anybody have questions? So these terms are super important. Barycenter, precession, and nutation. And that is also why you'll see them in your vocab. Okay, does anybody have questions?